Hey everyone, this is episode 5 of our study of AWS Solutions Architecture so that we can pass our exam together um, next year, hopefully next year. So in this video, we're going to review Elastic Load Balancer and Auto Scaling Group. How can we hide this thing? How can we hide this? Okay, we're able to hide it like that. So we are going to discuss elastic load balancer, and then an elastic load balancer routes your request of users. For example, this is a user here, and then it makes a request to, and then let's reverse this. How can we reverse this? There's supposed to be a reverse edit. Waypoint, add waypoint. Oh man, supposed to be okay, like that. Okay, so users, it makes a request to the load balancer, and then the load balancer will decide or randomly select, or whatever rule you will provide to the load balancer. It will redirect the traffic to the EC2 instances where your application is installed. And so for load balancers, you have classic load balancer, you have application load balancer, you have network load balancer, and you have a gateway load balancer. So for the um, application load balancer, it's a newer version of the classic load balancer. So the application load balancer, network load balancer, and the gateway load balancer are the new versions, the next generation of load balancer. And the classic load balancer is the old way, and I'm not sure if the correct term is deprecated, so it's not being used anymore. It's not being recommended. The recommended way is to use the newer way, the application, network, and gateway load balancer. For the application load balancer, I believe that is for HTTP and HTTPS, and for the network is for TCP, and for gateway, I forgot what's the gateway, but it's like it has its own firewall, I think, and the in the load balancer. I'm just discussing this on the fly, and but I'm not reading anything, just trying to exercise my poor way, so that poor articulation capabilities. I'm trying to exercise it publicly, shaming myself without exposing my face. All right, so that's it. And for so that is for the load balancer, and then we go to the auto scaling group. Um, do you need auto scaling? Is it required to have an auto scaling? Okay, so let's this time we're going to ask ChatGPT. Is it required to have an auto scaling group when working with elastic load balancer? Okay, so let's read. Okay, so no, it is not required to have an auto scaling group when working with an elastic load balancer, but using an auto scaling group with elastic load balancer is a common and recommended practice in AWS for managing scalable, high available applications. Here's how they relate and the optional nature of ASGs and ALBs. ELBs. Elastic Load Balancer. An ELB can distribute traffic across multiple EC2 instances to ensure that no single instance is overwhelmed with traffic. ELB supports different types such as Classic Load Balancer, Application Load Balancer, and Network Load Balancer. You can attach EC2 instances directly to an ELB, okay, without using auto-scaling. This means you can manually manage the number of EC2 instances that the ELB will distribute traffic to. In this setup, the number of EC2 instances is static, and scaling, adding, removing instances must be managed manually or using other methods like lambda functions or scheduled tasks. For auto-scaling group, ASG is a service that automatically adjusts the number of EC2 instances in your application based on demand. It can automatically add or remove EC2 instances depending on scaling policies, health checks, or other conditions. Okay, you can put policies. So aside from policies, health check, you can also use CloudWatch alarms. So I'm not sure if ChatGPT is going to recommend it to us, but let's continue reading. When combined with an ELB, the ASG will dynamically scale EC2 instances and register or deregister them with a load balancer as needed. This allows your application to scale automatically based on traffic. Oh, where are we again? Okay, the dynamically scale EC2 instances and register here with a load balancer as needed. Okay, so the auto scaling group ensures high availability and fault tolerance by maintaining a specific number of instances and replacing unhealthy instances. When you might not use ASG and ELB, if your traffic load is predictable and does not require dynamic scaling, you might not need an ASG. You can manually manage EC2 instances and register them with the ELB as needed. For smaller, less complex applications or when you're managing a small number of instances, you might opt for manual instance management rather than using auto-scaling. For the summary, ELB can function independently without ASG, handling traffic distribution to manually manage EC2 instances. ASG with ELB is typically used for scaling and automating the management of EC2 instances, especially in dynamic environments where traffic fluctuates. While it's not mandatory to use an ASG with an ELB, combining two offers more flexible, scalable, and fault-tolerant architecture. How about when you create an ASG? Is ELB required? Okay. No, an elastic load balancer is not required. Okay, so an elastic load balancer is not required when you create an auto-scaling group, but is often used together to improve the availability and scalability of your application. Here's how it works: ASG without LB. When you create an auto-scaling group, you can manage the number of EC2 instances based on scaling policies such as CPU usage, request count, etc. The ASG will ensure that the desired number of healthy instances are running, and it will replace unhealthy instances if needed. However, if you don't use an ALB, traffic must be manually directed to the instances in the ASG, and there's no automatic load balancing. For example, you might need to manage DNS records configure routing manually. This setup might be useful for scenarios where your instances are not serving web traffic, like backend processing or batch jobs, or if you're handling load balancing outside of AWS via a third-party solution. ASG with ELB. When you attach an ELB to an ASG, the load balancer automatically distributes incoming traffic across the instances in the ASG. The ELB ensures that traffic is only sent to healthy instances based on the ELB health check or the ASG health check. The ASG can scale in or out based on the load. This setup is ideal for web applications or any use case where you need to distribute traffic efficiently and ensure high availability of your service. Summary: ELB is optional when creating an autoscaling group. You can have an ASG managing EC2 instances without using ELB. However, ELB is highly recommended for most scenarios where you want to automatically distribute traffic across multiple instances in your ASG and ensure high availability and fault tolerance. In many production setups, combining both an ASG and an ELB provides the most robust and scalable solution for handling web traffic. Oh man, I forgot my question. I have a question in mind. Yeah, I think we've answered it. Okay, so for health checks. Okay, so your ELB can check the health of your EC2, or your ASG can also check the health status of your EC2 instances. Okay, so let's read this. In AWS auto scaling groups, both EC2 health checks and ELB health checks are used to determine the health of instances, but they work in different ways and serve different purposes. EC2 health checks focus checks the underlying health of an EC2 instance by evaluating its status in AWS. How it works: AWS checks whether the EC2 instance is in a running state, passes the EC2 status checks, which are separate from application health. Types of EC2 status checks: System status check checks for issues like hardware failure, network connectivity issues, or problems that are outside the EC2 instance itself. Instance status health checks if the instance is functioning properly at the OS level, software crashes, CPU, memory, or disk usage. Purpose: ensures that the EC2 instance itself is available and can communicate with the network. If an instance fails the health check, autoscaling will replace it automatically. ELB health check focus monitors the health of an EC2 instance from the perspective of the load balancer. How it works: the ELB health check monitors the application running on the EC2 instance by making HTTP, HTTPS, or TCP requests to a specific path or port. Purpose: ensures that the application is responding correctly. An HTTP endpoint is returning a valid response. If the instance fails the health check, the load balancer stops sending traffic to that instance, but it won't automatically terminate or replace it with ASG, thus with EC2 health checks. Key differences: Scope: EC2 health checks monitors the instance basic status up and down, while ELB health checks ensures the application and the instance is responding correctly. Actions taken: EC2 health checks can trigger replacement of the instance in the ASG, while ALB health checks only remove instance from the load balancer's pool. If it doesn't terminate the instance. Okay, so oh man, I can't breathe. ALB health checks only to remove the instance from the load balancer's pool, so it doesn't terminate the instance. And then for the EC2 health checks can trigger replacement if the instance is okay, so it will replace the instance. For the ALB, it will just remove from the pool, but for the EC2 health check, it will be replaced in the ASG. Okay, in practice, you may use both types of checks together. What is the difference between EC2 health check and ASG health check? The difference between EC2 health check and auto scaling loop health checks lies in their scope and what they monitor. Both are used to determine whether an EC2 instance is healthy and should continue running, but they operate at different levels. EC2 health check, we already read this above. For the ASG health check, ASG health checks monitors the health of EC2 instances in the context of auto scaling group and its scaling behavior. It checks whether instances are still part of the ASG and meets the conditions of being considered healthy based on the ASG's policies. How it works: ASG health checks can be configured to either EC2 health checks. This lies on EC2 instance status, similar to EC2 health checks mentioned above. ELB health checks: if you attach an ELB to the ASG, the health check will consider whether the instance are healthy based on ELB's health check, usually an HTTP request to an application endpoint or TCP. Okay. Action taken: if an instance fails the ASG health check based on EC2 or ELB health checks, the auto scaling group will terminate the unhealthy instance and will replace it with a new one, ensuring the desired capacity is maintained. Key differences: scope of monitoring. EC2 health check monitors the EC2 instances system and instance level. ASG health check monitors whether the instance is healthy in the context of auto scaling group using EC2 instance or ALB triggering actions. EC2 health check: if an EC2 instance fails in its health check, AWS can automatically stop or replace it depending on whether it's part of the ASG or not. ASG health check: if an instance fails the ASG health check, the ASG will automatically replace it with to maintain the desired number of healthy instances. Customization: EC2 health check focus on basic instance availability and functionality via AWS status checks. ASG health check more flexible and allows the integration with an ELB health check in addition to EC2 health checks, providing more granular monitoring of application level health. Summary: EC2 health checks focus on instance level status. ASG health checks monitor the instance health in the context of auto scaling group and can be used both EC2 health checks and ELB health checks. If an instance fails an ESG health checks, it will replace with the ASG to maintain the desired instance count. So yeah, for as you can see here in the diagram, users uses the ALB. The ALB can do a health check as we read in ChatGPT's response. EC2 health check or ELB health check. Yeah, we already read this. The EC2 health check if the instance is running or not. For the ALB, if the instance is not running, it will remove it from its pool, so it will not try to send route to it. But if for the EC2 health check, if it dies, it will just replace it with a new one. For the this is the minimum capacity of the auto scaling group, and this is the desired capacity, and it can go up to a maximum capacity if needed. So when creating an auto scaling group, you are required to use a launch template or a launch configuration. The launch configuration is the old one and the launch template is the new one. You can also trigger auto scaling based on a CloudWatch alarm here based on the metrics. So if the certain metrics is met, then it will trigger an alarm so that the auto scaling can take action on that alarm. So that's it for this. How many minutes is this? Oh, we got 19 minutes. Okay, so this is nice. Nice. All right, cool. Thanks. Bye bye.